Hi, everyone. Professor Hosmer here. Welcome to week 12 of Violent Python. Just want to check to make sure that you guys can hear me okay and see my screen. If anybody could just send me a chat or yell something out.
Loud and clear, and I can see what you're up to.
Okay, sounds good. Let's see. I wanted to check one thing. Sorry, I got a lot of windows open, and I apologize. Right. Okay. We are ready to go then. So tonight we're going to talk about natural language processing in Python. We're going to do some really basic things to kind of get you introduced to a new library called the Natural Language Toolkit that we're going to be using to process, mainly text files so that we can extract information from those files. Sorry, I had to close my door. Dogs were barking. So we're going to talk a little bit about what natural language processing is, and then we're going to talk about how to employ the Python Natural Language Toolkit, examining a fairly well-known corpus this week, and then we're going to experiment with some things with an LTK, and I'll show you what the assignment's going to look like this week. It's pretty straightforward, but there's a couple of steps that you can't miss if you are going to walk through this. So fundamentally, what is natural language processing, and maybe why do we care? Natural language is any language that humans learn from their environment and use to communicate with each other. Obviously, we do this every day. We're doing it right now. Whatever the form of communication, natural languages are used to express our knowledge and emotions and to convey our responses to other people, to our surroundings. The really cool thing about that definition by Mary D. Harris was it was created in 1985. So that means it was prior to things like social media. And I thought that it was really interesting that, she included in this definition emotions and responses to people around us, and wasn't really thinking about maybe the digital world when she wrote this original book and where this quote came from. But it really fits today. Sometimes great writers can actually write things that kind of stand the test of time. And even if the environment that we're operating in changes, the definition still works. And I think she achieved this here. So one of the questions is then, how can we judge their effectiveness? Well, judging the effectiveness of natural language systems that basically attempt to interpret, understand, and respond, those three things, they need to interpret the language, they need to understand it, and they need to respond accordingly. It falls into the Turing test, named after Alan Turing, based on his 1950 paper, Computing Machinery and Intelligence. In his paper, Turing asks the very provocative question, can machines think? And as we know, today, we are not there, but we are certainly moving toward that. The ability for machines to think, to be able to do those fundamental things that are here, interpret, understand, and respond accordingly. Obviously, we all use some sort of assistant today, whether it's, Siri or Alexa or whatever. And those environments can actually interpret, understand, and respond accordingly to many things, not everything, but to anything. And we're making progress in that particular area. So standing the test of time. Obviously, like all good definitions, they stand the test of time, since the internet really didn't materialize into some kind of recognizable form until the late 1980s. The concept of expressing emotions and knowledge didn't include Facebook, Twitter, emoticons, blogging, sexting, bit strips, or even the internet-based mail. However, the definition certainly covers provides coverage for these latest forms of natural language expression. I'm extracting meaning, semantics from natural language is quite a bit more difficult than it looks. That was a quote that I put into my Python forensics book back in 2014. So when we start to look at this, we want to make sure that we understand what we're talking about and how we're going to interpret natural language. And one of the great things is within Python, there are several third-party libraries that will perform natural language processing. We're going to focus on one, probably the oldest and revised, but the oldest version of that we're going to use this week. So one of the other definitions is really important this week, and that is, what is a corpus? A corpus, at least for natural language text, is typically a collection of written texts that focus on a specific topic, event, maybe an author or a genre that we want to be able to interpret. So we want to look at this corpus of information in order to be able to process it. Okay, really important. The Natural Language Toolkit has already been installed within the VLE for you. However, there's a couple things you have to do in order to make sure that the latest collections that are needed by NLTK are also installed. Those are not automatically installed for you because they change and they're updated. So we've installed the Natural Language Toolkit for you, but you need to take another step. So within the Python shell, within Wing IDE, you're going to import the NLTK first line. Then you're going to say nltk.download, and it will pop up this GUI. And you're going to click on the download button until it finishes, and it'll install all of the collections within your VM. So now you're ready to go in order to be able to start using the Natural Language Toolkit with this week's assignment, and also to be able to experiment with it. So just make sure that you follow the steps or nothing is going to work for you. So what I want to actually do is kind of give you a quick little demonstration of how you're going to be able to tell. And I've included in this week's D2L page a script called the simple word part of speech tagger .python script. And this is a really kind of an interesting way to think about the power of what the Natural Language Toolkit specifically can do for you in order to do this. This is just one example, but I wanted to basically show you how this is done. So we're going to basically, from the Natural Language Toolkit, we're going to bring in two of the functions or modules within NLTK, the part of speech tagger and the word tokenizer. You're kind of somewhat familiar with word tokenization because in the simplest form of word tokenization, we would take a piece of text and use the split method. If it's a string, we can use split and get the individual strings or individual words, if you will, within that particular string. That's what word tokenizer does for us. I'm also going to bring in the pretty table, and I like to be able to translate the parts of speech tags that come back from NLTK into something readable. So in this little dictionary that I've created, it basically says POS tags, and it says what those tags and what the meaning, if you will, of those tags are, so we can actually display those. So let me step through this script for you. It's really simple, and you should do the same thing. The really importance of this script is you'll be able to execute this script, and if this runs after you did the preceding steps that I had mentioned, right? If you had done this process and it was successful, this next step will actually prove that you got everything up and running. That's one of the reasons I provide this script. So again, I'm going to, from the Natural Language Toolkit, I'm going to bring in the part of speech tagger and the word tokenizer. And you notice that took a little while to load. The Natural Language Toolkit library is quite large, and you'll see why in some of the things that it's able to do. So I'm going to bring in a pretty table so we can actually pretty up the output. And now I'm going to actually create this dictionary. And you notice that I initialized the dictionary in one statement. If I put my cursor over part of speech tagger now, we have a traditional dictionary. Opens with a squiggly bracket. CC is a conjunction, CD is a cardinal number, DT is a determiner, and so on. So these are all the different parts of speech that NLTK can identify. Really an exhaustive list, being able to separate the difference between an adjective and an adjective comparative or an adjective superlative. It is very rich in its ability to identify these characteristics of speech. So just again, to show you how this works with a simple sentence, not a corpus, just a sentence, I'm going to basically say, hey, this is a sentence that I want to be able to interpret. So now I have a string that is sentence. I will get voting rights to be a reality for everyone. And I'm going to basically use the word tokenizer to tokenize that particular sentence. Fancy word for basically splitting it out into the individual words. Because if I look at English text now, you get what you would expect, almost exactly what you would get if you were doing split. Based on that, though, now that I have a set of tokens that I can process, I can ask NLTK, now that I've got the tokens, I can say, okay, give me the parts of speech of every one of the words in that particular sentence. So if I step over that, I can put my cursor over tags, and it has broken down now another list that's come back, and each element of the list is a tuple that basically has the word, and assigned to that word is its part of speech. So now what I'm going to do is I'm going to iterate through each one of those, and I'm going to add a row to my table until I'm all done. Set a breakpoint here and just say go. This was the original sentence. I'm going to align my table to the left because that's the way I like it. And now I'm going to print out the table. So the table basically says, here's the words, here's what the part of speech coding is, and this is what it means. So just in a couple lines of code, we've been able to take that particular sentence and break it down and determine what every part of speech is in that particular sentence, according to the Natural Language Toolkit, which is built on this collection of libraries on how to interpret that kind of sentence. And again, I provide this for a couple of reasons. I want you to see the kind of value we can get from the Natural Language Toolkit, but also to verify that your environment is working okay. Whoops. Any questions on that so far? And now that I've done this in the demonstration, I want to take you through what you're going to do this week. So before I do that, any questions so far on what I have shown you so far with the tagger capability to be able to tag the parts of speech of every word within a sentence or something larger? Any questions? Okay, so now you can all update your LinkedIn profile and say that you know natural language. Okay, so this is what the NLTK assignment, and as normal, I've given you the starter script that you're going to be able to work with, and this is what you're going to do. You're going to basically use this starter script as a basis for what you're going to do in this week's assignment. And so what I want you to do is do some research on the Natural Language Toolkit. And if I bring up the dashboard, wrong one, course home, content 212. I've provided you a link to the naturallanguagetoolkit.org where you can read about the online documentation and understand all of the functions and capabilities of NLTK. You're going to be using some of those, so you're going to have to research how to actually do those. But I've teed up the starter script for you, so you're going to basically start to fill in the blanks. So going back to the script one more time, what I'm going to do is give you a quick demo of this, and most of the script is empty, right? But some of the functions I filled in for you, in this table. So I'm just going to say go, just to kind of show you what you can do. And then I'll show you the areas that you're going to fill out. So remember, got to kill the other script. So what this is going to do is basically put up a menu, and these are the items that you're going to get from the corpus that we have. So I've provided the corpus information for you within D2L as well, so you can load in that corpus. Remember the way this works, all of the corpus files are going to be one level below your script. So when you install this, when you have the script there, you're going to basically take the corpus that I provided you with, which is a portion, just to give you what it is. It's a portion of the O.J. Simpson trial transcripts, just so that we have something that we could kind of take a look at. So the path that we're looking for is /corpus. And so it's bringing in several of the files. So I'll show you how I did that in a second. But then it basically is just going to paint this menu for you, and then you're going to make a selection. So one of the first things we might want to know is, well, how big is the corpus? What is its length? So I can say 1 and hit enter, and it says the corpus length is 744,022. It's basically the number of characters that were found within all of those files that were loaded into the corpus, just to give you an idea of the size. If I want to know how many tokens there are, I can press 2, and it comes back and says, okay, there were 153,683 tokens, a la kind of sort of words that it found within the corpus. So the first one gave us the total length of the corpus, the number of characters that were in the entire corpus. The second was the number of tokens found, alias the number of words that were found within the corpus. So if you kind of take a look at this, all of this is built for you. And now what it's going to do is you're going to basically fill in the rest of it. So you notice that in my menu selection, you enter in the selection, and then it could be print the corpus length or print the tokens. So those are part of this object that I created called O object NLTK. And up here in the code, these are all of the functions that we're going to be calling. So you notice that in the print corpus length function that we called when we specified print the corpus length, okay, it basically said self.raw text. So that was one of the pieces of information that we already collected during the initialization of the object. The second is the number of tokens. And again, that was also collected, self.tokens was got from NLTK word tokenizer and got the raw text and used that. So those gave you the first couple of things that you needed. What you're going to do now, okay, is all these places where it says your code goes here, you're going to fill in what you need to do in order to be able to get things like the vocabulary size, compiling the top 100 collocations. You're going to basically search for a word, and I give you some words that you will be searching for within D2L. You're going to build a concordance of that. Some of these terms may be not familiar to you, or what similarities mean. Those are the main ones, but you're going to learn that by going through the NLTK documentation and getting an understanding of what a word concordance is, a similarity is, how you get the vocabulary size. All of that is basically in the Natural Language Toolkit documentation that I gave you a link to, and that's what you're going to do. So this week you're going to fill in the code for each one of these functions that actually goes out and collects that information, and you're going to be using obviously the NLTK toolkit in order to be able to do that. And that's what you're going to be doing this week. So just kind of giving you a good introduction to the Natural Language Toolkit. We will be using this later in the semester as well. So make sure that you focus on this assignment so you get a familiarity with the Natural Language Toolkit and with some of the functions that you're going to be able to be used now, but also going to be using in the future in other assignments. Any questions now? Pretty straightforward, or is there parts of this that are confusing?
It seems okay to me.
Cool, Steve, thanks. Yeah, so it's it's a way to kind of introduce you to natural language processing, kind of ease you into it a little bit, and start to use one of the major Python third-party libraries out there that is open source that you can use to do this. And we apply this when we go to the machine learning class, which is the next class in the sequence. Sorry, let me kill my email here. In the machine learning class, which is the data analytics with Python, the next class in the series, which is 474, we extensively use the natural language toolkit to process things like news stories and tweets and examine sentiment within social media posts, that kind of stuff. So we're using this library extensively to pull information out that we can use. So this is just giving you a taste of this to kind of get you started with using the natural language toolkit. So it's something that we use in so many different aspects of data analysis and data science when we're actually trying to take information that is related to text. And remember, if it's spoken text, we can convert that into text so we can process that. And we do that in the machine learning class. We've actually processed, for example, one of the presidential debates and take all of the responses from every one of the candidates and basically analyze it and compare it. So there's some really great ways that we can use this particular tool along with other machine learning libraries to basically process that. So it should be a fun week, and you can use the corpus that I provided. That's what you need to do to solve this particular exercise. But once you get a flavor of that, you may want to actually bring in other textual data that you might want to process using some of these same functions or more. And no, it was it's pretty good. They have people that are recording that, John, and analyzing that, and every word is perfectly done within the process. So really interesting that you bring that up, because it's one of the nice things about using and converting spoken word by a person and then analyzing the language that they use. You know that it's coming from that person, especially if it's in an impromptu kind of environment where somebody's asking them a question and they have to respond, right? So we know it's them, not some writer for them or a group of people that are trying to determine how to make a post or write a news story. You never know who's really doing that. One of the nice things about analyzing something that came from a speech that was impromptu, you're getting a really better idea of the kind of language that that particular person uses when they're actually trying to explain whatever the topic might be. So it's not something that is canned, in other words, or written by someone else. So it's really a cool examination of how, in this case, candidates basically responded to questions that they were asked. And even what kind of words do they use? What are the things that we call bigrams and trigrams? In other words, two words that they bring together or three words to bring together. Does that make their speech unique? So just a lot of really neat things that we can do with this particular library. Any other questions? Any other comments? Good comment, John. That's exactly the kind of thinking. Where did this information come from, and is it accurate? We're feeding in data that didn't really come from the subject. Does that really provide us any value? So really good comment.
we got any tips on creating a transcript of output? Because when you're going through a menu item, you're iterating, you're providing input, doing processing, providing output, and then you cycle through, and you can't always kind of screenshot your way through. The screen isn't big enough for all the content. So do you have is there like a right click save as on the debug IO window or something?
Yeah,
like
sure.
that
I think I understand the question. Yes, there is, because there's going to be a lot of output that comes out of this. And one way to capture that is to modify the script. So for example, every time that we have an input and an output that comes up, right now we're printing it out back to the screen. But you could have also, for example, created a file, and then for every result, you could actually put this out to the file by using a write method on that particular file. So you can do that. The other thing that you can do is you can redirect standard out. Since this is a standard output, you could redirect standard output to a file. And then everything that you print, okay, using the print function will go to standard out. And then you could, in standard out, you could be redirecting that to a file, for example. So by redirecting standard out to a file within Python, then everything that is output by the script would automatically be redirected to the file instead of to the screen.
Wouldn't you have problems using it interactively then?
Well, no, because yes, exactly. So in that particular case, certain parts of the script are going to have to be prompted to the screen, right? So you'll have to switch between the outputs. So you can basically change dynamically standard out to be, in certain cases, be going to a file, which are basically the output from that perspective. Or you could, and again, one way to do it would be right here. If I had a file, right, that I had opened, and I said, it says out file dot write, I could basically take everything that's going to be done here and put it into the write file, and output file write, and whatever that output file is will get all of that data. Keep in mind, when you do that, these commas here that bring in different things, they'll have to be replaced with plus signs, because we have to concatenate that stuff together. I can't do that with the commas like we're trying to format the output on the screen, but that's a minor fix. And then you could, for every one of the outputs, you can basically have it go right to the, duplicate that to go to there and to the screen and to the file. So that would be another way to kind of tackle that output. Otherwise, you have to basically come down here and, you can use Control A and collect everything from debug IO and then save that to a file. Any other questions? Elizabeth, I see that you're on the line. Thanks for coming tonight to help out. Any questions that you have received that I should cover, or your experience with this particular assignment? I know there always is questions. So any hints that you want to give to the students from your point of view?
I'm trying to think, because I do remember we did get a couple questions last semester regarding this assignment, but I have to double check to see what it was. So I will do that, and then I could put that in the weekly announcement once I look back at that.
Okay, thanks. That would be helpful for everybody, I'm sure. Remember, we'll have a Python tutoring session on Saturday and office hours next Tuesday. Note that because I moved the office hours to Tuesday and the lecture to Thursday, I also went back and changed the due dates for the quizzes and assignments to align with Thursday instead of Wednesday. So your assignment last week was not due till today, and the following weeks they'll be due all on Thursday. Both the quizzes and the assignments will be aligned with the next lecture as they normally are. So I did make that change to D2L to the assignment due dates. Okay, if there aren't any questions, I will sign off and post this video back tomorrow, and look forward to seeing you on Saturday if you have any questions, or on Tuesday for the office hour. And other than that, have a fantastic rest of the week and weekend. Take care, everybody.
Thank you. Goodbye, all.
Thank you.
Welcome.
Thank you. Bye, everybody.
All right, have a good one.